What's up, geometry students? We're talking about tangent lines. It's a good lesson that kind of connects the beginning of this unit to the end of this unit. The key thing is that the tangent line just touches the circle at one point and is perpendicular to the radius. We know about perpendicular lines, they have opposite reciprocal slopes. So if we were to understand that this slope was up 4/3, then this slope of this tangent line would be -3/4, and they share like this point, 3, 4. So the equation of this tangent line, since it has this point 3, 4, would be y minus 4 equals this opposite reciprocal slope, x minus 3. So that's one thing. The other thing is understanding what would be perpendicular to something horizontal. Well, something perpendicular to something horizontal is something vertical. Vertical lines have one thing in common. All of their x coordinates are shared. They're all going to be the same x value, whatever the y is. This vertical equation is this vertical line has the equation x equals the x coordinate. And this would be a tangent because it's perpendicular to this point on the circle -5, 0. And conversely, if we went up here, we could see this is straight up on my circle. This line right here would create a 90-degree angle. What creates 90-degree angles and ups and downs, vertical things, horizontal things? This equation is a y equals equation because all of the points have the same y coordinate. Okay, so what's perpendicular to horizontal? Vertical. What's perpendicular to vertical? Horizontal. Understanding the equations, understanding that this slope is undefined versus this slope, which is 0. Vertical things don't have a defined slope because it has rise and no run. Horizontal things have runs and no rises. So let's get to it. We have this point -1, 2. We have this radius of 5. Q is a point 2, 6. P is the point 3, -1. What is the equation of the tangent to P? Okay, so here is the radius that connects C and P. Cool. And we could calculate that slope if we wanted to, just by doing rise over run, or if we wanted to kind of put the -1, 2 down, and then the 3, -1, we can see I'm going down 3 as I go over 4. So down 3 over 4. The slope is -3/4. Many students are getting the wrong signs of the slopes. Lines going down from left to right, the slope is negative. We're decreasing our y's per x. So what is this equation? Well, y minus y1 equals this slope has to be perpendicular. This line has to be perpendicular. This slope has to be +4/3. What about q? Well, you can see you're going up 4/3. So this slope is actually the same as this slope, which is interesting. That means this line has to have a slope that is the same as that slope, -3/4. How do we know the two lines are perpendicular? We examine the slopes. Okay, well, what if we have this circle centered at the origin with a radius of 3? What are these 4 tangent lines? Well, we have this vertical tangent line, which is going to be perpendicular to this horizontal radius. This line, this vertical line, all of the x coordinates are 3. This coordinate is 3, 1. This is 3, 2. This is 3, -1. This is 3, -2. This is the line x equals 3. If I popped over here, this would be the tangent line, which is perpendicular to this radius. Vertical things, horizontal things create that right angle. This line would be x equals -3 because all of the coordinates would have an x coordinate of -3. If I go up or down, well, here would be the radius. Here would be the tangent. That's perpendicular. Vertical, horizontal creates perpendiculars. What's this equation? It's a horizontal line. All of the y coordinates are 3. So y equals 3 versus this line here, since it's horizontal, would be y equals -3. Now, here's the key, guys. The slope of this line is undefined. It's got rise, but no run. You're not allowed to divide by 0, which is why we say the slope is not like existent. This slope of this line is 0. Undefined slopes, 0 slopes, perpendicular to each other. All right, we got a circle centered at 3, 4, the radius of 3. I'm just going to go ahead and give myself 4 points that are easily found, right? Just like we kind of have been doing, like those points that are easily countable, like whether it's left 3, up 3, right 3, down 3. The equation of the circle, we have this xy, we have this point 3, 4, and we have this radius 3. This length would be x minus 3. This length would be y minus 4. We understand that 3, 4, x, y. You would subtract the two numbers to find the rise and the run, these lengths, and we use the Pythagorean theorem, a squared, b squared, c squared. So x minus 3 squared plus y minus 4 squared equals c squared. Too many students on their quiz did not understand when to put c and when to put c squared. So you need to practice it. What's the 4 easy points? Oh, okay, well, this is 3, 4. We have a radius 3, so I went down 3, so I subtracted 3. This is 3, 1. What is this? 0, 4. What is this? Well, I added 3 to 4. It's going to be 3, 7. What's this? It's going to be 6, 3. Or 6, 4. That's adding 3 to the x. Cool. Write the equation of the tangents of the circle at the 4 easy points. Is the x-axis or the y-axis one of the tangents? Well, let's see. At this point here, we see we have a vertical tangent because this is like straight to the right. Here is a vertical tangent. What are these equations? Well, vertical lines, all the same x coordinates. All these points have an x coordinate of 6. All these points have an x equals x coordinate of 0. So x equals 6 and x equals 0. Oh, wait, x equals 0 is the y-axis. Cool. What about the other ones? Well, like up here, this horizontal line would be tangent to or perpendicular to this vertical line, and same down here. So all of these points have a y equals 1, and all of these points have a y equals 7. Are either of those the x-axis or the y-axis? No. If it was y equals 0, that's the x-axis. One, 2, 9, 4. Okay. The points are the diameter of the circle. So these points are a diameter of a circle. So there's some circle. We'll pretend that's a circle. If the points are the diameter circle, find the center of the circle, which is the midpoint. So let's find the midpoint. I'm just going to do it by kind of like understanding the lengths, just splitting them in 2. If this is plus 8, I'll add 4. If this is plus 2, I'll add 1. Or you could have found the average of 1 and 9 and 2 and 4 and get the middle numbers. The middle is the 0.53. Too many students are not writing the midpoint as an XY point. Okay, now find the equation of the circle. Well, here's where we need to figure out what is the radius of the circle. What is this length? What is that entire neck? Now, we don't want to use 1, 2, and 9, 4. We kind of want to forget about this 1, 2. We just want to use maybe 5, 3, and 9, 4. We want to use the point in the middle and the point on the outside, though you could do something else if you wanted to. But now we're considering that this length is 4 and this length is 1. And we'd figure out the length of the radius, 4 squared plus 1 squared equals c squared. This is 17 equals c squared. Too many of you were freaked out when you got an answer to a question that could not be simplified. Not everything can be simplified. The radius is root 17. Okay, that's the radius. Now we talk about, well, let's talk about just a random XY point. We kind of change gears and we think to ourselves, okay, well, this length is going to be y minus 2. Sorry. What is this point here? 5, 3? This point is 5, 3. This is the center, so y minus 3. This point here is x minus 5. People who don't draw and really understand where the equation comes from, since they have this point here and this point here, you don't know which point goes into it, and you're just trying to fill in information into an equation, and you don't know what you're doing. So, like, the picture is always going to help. And you now know that this is root 17. But here's another mistake students made. X squared, a squared plus b squared equals c squared. Root 17 squared is 17. That's what c squared is. That's what we have. So we got that. Find the equation of the tangent lines that pass through both points. Okay, so here we go. We want this tangent line and we want that tangent line. We realize they're going to be parallel to each other. Why? Because this is a radius with a slope of 1/4. This is also a radius that has a slope of 1/4. If this slope is 1/4, the slope of that line has to be -4. So let's do it to the 0.94. I have y minus 4 equals, you have to understand the slope. Again, you have to do triangles, rise over run, and then that's got to be -4. Again, that's like the new thing to this lesson, that these tangent lines create perpendicular angles. We know slopes can be found easily, and now we have these perpendicular slopes. And what about at the other point, 1, 2? We'd have y minus 2 also equals -4 x minus 1. So it's like we did all that work, but then for the tangent equations, we don't really worry about other stuff we're doing. We're kind of resetting, we're restarting. We think about, okay, what are the radiuses? What are the slopes? It's the same as the slope as that line segment. Slope is 1/4. So that means the slope of the tangent line has to be -4. Since this is 1/4, the slope of this has to be -4. Since this is 1/4, the slope of this has to be -4. And then we use point slope form, which some of you still are not embracing using point slope form. Last couple questions are a little bit tricky, so let's pay attention. We have this ATP. We have APT is 45 degrees. Okay. We know this has to be 90 degrees. If this is 90 degrees and this is 45, this has to be 45. That means this length must be equal to that length. Because it's an isosceles triangle, opposite sides are going to equal if opposite angles are equal. So TAP is also 45 degrees. ATP is going to be 90 degrees. What's the length of AT? Explain why. Well, the radius is 10 centimeters. So that's that. But what about AP? Well, if this is 10, this has to be 10. AP has to be the hypotenuse. A squared plus B squared equals C squared. C is opposite the 90-degree angle. You're going to realize this is 10 root 2 because this is going to be like 200. Which is, after square rooting, root 2 root 100, which is 10 root 2. It's a good question. I know that's got to be a 90-degree angle because it's tangent. What can we conclude about BP and OP? They're not equal to each other. They are the legs of, oh, they're perpendicular. OP. Oh, wait, BO is 17. OP, AB. Okay, okay. Well, we got to find OP. Now, how do we find OP? A squared, B squared, C squared. So A squared plus B squared equals C squared. I don't know what 17 squared is. Okay, so 225. Too many people, when squaring numbers, either don't have a calculator or think you're multiplying by 2. 289. 289 minus 225 is 64. That means A has to equal 8. It's really plus or minus 8, but we're just going to call it 8. If A is 8, then AO is also 8. And if AO is also 8, then AB has got to be 9. Doesn't look true. But how do I know that? Because 8 plus 9 is equal 17. Yeah. Why? When we draw a diameter and then we just connect things like this, why does this have to create a 90-degree angle? This is not really having to do with tangents. This is just more like interesting, which, see how interested you are. It has to do with the fact that, what does it have to do with? It's got to do with like these radiuses. This is equal to that. That's equal to that. which means this angle is equal to that angle. This angle here has to equal that angle there. We can call this angle 1. This is angle 2. Sorry, this will also be angle 1. This will be angle 2, and this is angle 2. We know 1 plus 2 plus 1 plus 2 has to equal 180. We know doubling 1 plus 2 has to equal 180. Therefore, 1 plus 2 has to equal 90. Yeah, it's like this is good geometric thinking. Maybe a couple of you understood this, but really this is not important to the lesson on tangents. Please don't stress about this problem, but it's good. It's just a challenge. But the equations of tangents, the equations of tangents at the verticals and the horizontals, all those things are important. All right. All right. Good luck out there. Peace.